The United States Department of Transportation has initiated a connected vehicle pilot deployment effort. Local transportation agencies, cities and municipalities, and private industry will be invited to submit cooperative pilot proposals for funding and support. These pilot programs will produce operational deployments that will harness the capabilities of connected mobile and wireless technologies to provide mobility, safety, and environmental benefits. The U.S. DOT will seek partnerships among state and local transportation agencies, commercial vehicle operators, private companies, and others to select and deploy appropriate connected vehicle solutions from across all elements of surface transportation, such as transit, freeway, arterial, parking facilities, tollways, or ports, to address local needs and performance goals. The local partners will select from among many beneficial applications to address their most pressing needs. Now I will go through the HALLECK Expressway scenario, a hypothetical 10-mile urban freeway named for a Civil War general and influential figure from the early history of California. The expressway is plagued by several substantial issues, including multiple interchanges, a bottleneck at the Colfax S-curve, frequent minor and occasionally major incidents, and limited arterial diversion routes. As a consequence, the expressway is heavily congested and suffers from unreliable travel times. This slide illustrates the HALLECK Expressway during a traffic incident. Traffic is at a standstill due to the incident, and no communication is occurring within the system. As a consequence of the incident, heavy trucks have exited the freeway using arterials and are moving through residential areas. Local jurisdictions do not coordinate their operations effectively, resulting in increased delays and other problems. Local stakeholders convene to discuss their key transportation challenges related to the HALLECK Expressway and agree with the items on this slide. The Colfax S-curve is a natural bottleneck, and the multiple interchanges with their merge and weave delays lead to recurrent congestion. Response to major incidents lack coordination among agencies, and the frequent minor incidents make travel times unpredictable. Arterial diversion routes have limited capacity and are easily overwhelmed, so mass diversions lead to gridlock. Based on the challenges they identified, the local stakeholders discussed performance measures and improvement targets. The stakeholders aim to improve the Colfax S-curve throughput by 8% during peak periods, reduce major incident delays by 25%, and adopt a zero-tolerance stance for arterial gridlock during incidents. The stakeholders then consider the range of application options. To improve bottleneck throughput, the stakeholders review the full list of connected vehicle applications for mobility, safety, and the environment, and select the emergency electronic brake lights and the forward collision warning vehicle-to-vehicle safety applications, and the dynamic speed harmonization and the queue warning mobility applications. These applications will help maximize throughput without geometrically altering the freeway. In order to reduce incident delay, the stakeholders select the incident scene pre-arrival staging guidance for emergency responders and the incident scene work zone alerts for drivers and workers mobility applications. Respectively, these applications coordinate first responder efforts and alert traffic in and around incident areas to improve safety. Finally, to enforce the new zero-tolerance policy for arterial gridlock under incident conditions, the stakeholders select the Advanced Traveler Information System and the Intelligent Traffic Signal System mobility applications. ISIG deployments will facilitate a smoother flow of traffic, while Advanced Traveler Information System concepts will provide travelers with real-time updates on the status of the freeway and other transportation facilities to prevent over-diversion onto arterials from en-route drivers, as well as informing travelers that have not yet begun their trips along the freeway. In summary, here are the 6 applications selected by the stakeholders for deployment on the HALLECK Expressway. The next slides show how these applications are projected to work in concert to improve mobility and safety. This slide illustrates the emergency electronic brake lights application that was selected to improve bottleneck throughput and is projected to reduce traffic shock waves and facilitate flow. The other bottleneck throughput applications will increase bottleneck throughput by 8%, with in-vehicle warnings providing drivers with stoppage information to reduce crashes and incidents and their resultant diversions, and the improved flow results in faster major incident response. This slide illustrates the incident scene work zone alerts concept, with headquarters broadcasting news and warnings to drivers near an incident through a roadside unit. Impacts of all the incident management applications include a 25% decrease in major incident delay due to improved coordination and incident scene management, improved bottleneck throughput, and a decline in over-diversion onto arterials due to reduced impacts from incidents. This slide depicts the intelligent traffic signal system that will improve flow on the arterial streets near the HALLECK Freeway, especially when drivers may divert from the freeway. Working in concert with other diversion management applications, crowdsourced arterial travel times made available to drivers allow them to make better decisions regarding route choice and time. These deployments will help prevent mass arterial diversions and associated gridlock. In closing, this slide illustrates the fully integrated application deployment concept for the HALLECK Expressway. Vehicle-to-vehicle safety applications are also improving traffic incident management deployments. Vehicle probe data is integrated with the freeway sensor system, allowing transportation management systems to harmonize traffic flow. Traffic signals adapt in real time to prevent gridlock. Crowdsourced data prevents mass diversion onto arterials and into communities. And local jurisdictions and agencies have integrated their operations and can now coordinate multi-agency responses to incidents and situations. The HALLECK Freeway is now safer and more reliable, and the surrounding communities are safer with reductions in diverted traffic and smoother flow.